Hi everyone, this is Mrs. GA, and today we're going to learn how to graph sine and cosine. Alright, so we're going to start by graphing the parent functions of sine and cosine. So to help us find the coordinates for sine and cosine, we can actually use our unit circle. So a quick reminder, in the unit circle, the coordinates of the unit circle represent cosine and sine of that angle. And remember, the x value of the coordinate represents cosine, and the y value represents sine. So we're going to start by graphing sine, which means we're going to start with the y values of the coordinates. Now if you look at the scale of my graph over here, I'll zoom in a little bit. We're counting by pi over 4, but I'll just take all the coordinates from pi over 2, pi, 3 pi over 2, and 2 pi, just to make it a little bit easier to plot the points. So I'll start here. The sine of 0 degrees is 0, so my first coordinate is 0, 0. The sine of pi over 2 is 1, so I'm going to plot that coordinate. I'm actually going to change the scale of our graph too, just to make it a little bit easier to see. I'll say that each tick mark is 1/2. So pi over 2, 1 would be up here. Okay, the sine of pi is 0, so we go back to 0, pi 0, and the sine of 3 pi over 2 is -1. And then last, if we get back to 2 pi, which is coterminal with 0, the sine of 2 pi is also 0. So here we have what's called one full period of our sine graph because we've made it back to our starting point. So we can actually kind of do the same. We can replicate the same pattern going backwards. So if I work my way backwards, I know that negative pi over 2 would be at -1, negative pi would be at 0, negative 3 pi over 2 is at 1, and negative 2 pi is at 0. So it kind of continues that wave pattern, but going backwards. There you have it. So for cosine, remember we're going to be using the x values of our coordinates now. So I'll graph this one in red. So let's start with the cosine of 0, which is 1. So our first point is going to be at 0, 1. Again, let me adjust the scale of our y-axis. There we go. Okay, and then let's look at pi over 2. So I know that the cosine of pi over 2 is 0. So I'll plot that point, pi over 2, 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0. And then the cosine of 2 pi brings us back to 1. So right here. So this is what one period of cosine looks like. So you'll see that it still has that wave shape, but instead of starting at the midline right here at 0, 0, we're starting at the maximum and then returning to that maximum. So in the same way, we can kind of repeat that pattern going backwards to give us a second full period of cosine, just like this. And there you have it. Here we have 2 full periods of cosine. So you notice that for both of these graphs, they actually have the same domain and range. So remember, our domain are x values that are defined for the function. If you see, this graph is just going to continue infinitely to the right and left for both. So our domain is all real numbers, so -infinity to +infinity. But our range is restricted. So you see that both of these have a clear minimum value at -1, and it does have a coordinate at -1, so it's included. They both also have a clear maximum value at +1. So this is going to be the domain and range for both sine and cosine for their parent functions. So when we start graphing more complex equations of sine and cosine, we are going to use those same transformation rules that we've been using for any other type of function we've covered. So it's going to change our graph in the same way. However, sine and cosine have a few pieces of vocabulary that are important to know that tie into these transformations. So you can see here's a sine graph, and here we have a vertical stretch or shrink, a horizontal stretch or shrink, a horizontal shift to the left or right, and then a vertical shift up or down. And also remember for this k value, the horizontal stretch or shrink is always by a factor of the reciprocal, so 1 over k. And for this shift, it's always going to move in the opposite direction that you think. So first, let's talk about what's called the amplitude. So by definition, the amplitude of our sine or cosine function is the distance from the midline of the function to the maximum or the minimum. So if you double the amplitude, that's the total distance from the very top to the very bottom. So the amplitude, since it's the distance going up or down, is of course affected by a vertical stretch or shrink. So essentially our amplitude is always going to be this a value. So whatever this is, that's going to be what we call the amplitude. We already talked about this word period. It's the length of one full cycle. And for our parent functions, again, that full cycle is 2 pi, which is one full rotation of a circle. Now, this period can be affected by a horizontal stretch or shrink. So this value right here will change the period. So notice that I take the period and I multiply it by the reciprocal 1 over k. So this is kind of a formula. We say that it's 2 pi divided by whatever this factor is. Last, the phase shift. Phase shift is just a fancier way of saying a horizontal translation. It's a shift left or right. So this will be affected whenever you see something added or subtracted specifically from x. Now it is really important that if you have a horizontal stretch or shrink in addition to a shift, it's important that we have factored this k value out before we determine what the shift is. Okay, so let's give one of these a try. So here we're going to approach graphing these in a few different ways so you can kind of pick and choose which parts work really well for you. So you'll see here that I have a t-chart set up so we can get some exact coordinates. So let's start by first writing in the parent function coordinates. So for sine, we can use 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and then 2 pi, 0. And then we're going to look at the transformations we see in the equation and see how those would affect our coordinates. So a few different things that I see that our graph is shifted down 1. We have a vertical stretch by a factor of 2, and we have a horizontal shrink by a factor of 1 over 2. Remember, it's always going to be the reciprocal here. So that means that when we change our coordinates, we're going to follow these rules. We're going to do 1/2 x. So this is our horizontal shrink. And then we're going to do 2y minus 1. So this is our vertical stretch, and then we shift down 1. So now we can apply these rules to these 5 coordinates to give us the coordinates of our transformed function. Okay, so here are the 5 transformed coordinates. Again, I just multiplied all of my x values by 1/2, and I multiplied all my y values by 2, and then subtracted 1. So before we start graphing these, let's determine what the amplitude and period of our graph are. So the amplitude is going to be this value, whatever our vertical stretch or shrink is. So here our amplitude is 2. And remember, that's going to be the distance from our midline to the max or from the midline to the minimum. And then to determine the period, remember there is a little formula that you can use. It's just 2 pi divided by whatever value you see right here, which is pi. Or remember, this is just taking your original period and changing it according to this horizontal shrink by a factor of 1 over 2, which is why we essentially divide by 2. Okay, so before we start plotting our points, I'm going to take a little bit of time to actually set up our graph. So my first tip for you is in how to scale your x-axis. So my tip is take your period, which in this case is pi, and then we're always going to split it up into 4 parts. So this is going to be the scale of our graph, and you'll see why this will help us in just a minute. So in this case, each little tick mark on my x-axis is going to be pi over 4. So that makes this pi over 2, 3 pi over 4, and pi. The next thing I want to do is I like to actually trace in my midline, and then I like to trace in where my maximum and where my minimum values will be. So since my graph was shifted down 1, my midline is also going to be shifted down 1. So in the parent function, the midline is right at the x-axis. So that means that our new midline is right here. So I'm going to just sketch it in lightly, just as a guideline. The next thing I need to find are the maximum and minimum values. And I can do this using the amplitude. So our amplitude is 2, which remember is the distance from the midline to the maximum. So I'm going to start at my midline and I'm going to draw a line 2 above it. And then I'm going to go back to my midline and then go 2 down. So this will help me plot my points a little bit quicker, and it will also kind of remind me, okay, here's my middle. This is where I stop and turn around, back to the middle, and then I go back to the bottom. So this, again, is just a guideline. You don't have to do this, but I found it to be pretty helpful. And now we can start plotting our points. So really, if we start at this first one, which is at 0, -1, I can really just split this up into 4 parts, 1, 2, 3, 4, and it will go up to the maximum, back down to the middle, down to the minimum, back down to the middle. And there's one full period of sine. So again, we know that sine always starts at the midline, and then its first movement is to go up, and then it goes back down to the midline, and then it hits the minimum, and then it returns to the midline. So we can actually continue this pattern going to the left, and it's really easy if you have your graph set up. So we just go 1, 2, 3, 4, and then connect your dots. So this is why I like to always take my period and divide it into 4 to do my scale, because then when I go to plot them, these are really the 4 quadrants from our original graph. So it makes it quick and it makes it very accurate. Okay, let's try another example together. So this one, we're going to be graphing cosine. So we'll start with the parent function coordinates. So remember, cosine starts up at the maximum. So it starts at 0, 1, and then pi over 2, 0, pi -1, 3 pi over 2, 0, and then it returns at 2 pi to the maximum at 1. So now we're going to look at what type of transformations we see and determine how it will affect our coordinates. So here I see that we actually have a horizontal stretch by a factor of 2. Remember, it's the reciprocal. And then I see that we have a vertical reflection because of the negative. And then we also have a vertical shift up 1. So this will affect my coordinates in the following way. I'm going to multiply all of my x values by 2. That's my horizontal stretch by a factor of 2. And then I'm going to multiply all my y values by -1 for the reflection, and then add 1 to shift everything up 1. So we'll take a moment and adjust our coordinates in our t-chart. Okay, so here's the coordinates of our transformed function. Now let's look to see if we can determine the amplitude. So remember, the amplitude is any vertical stretch or shrink, which there isn't any, so it's going to stay at 1, just like the parent function. Remember, for the period, we do 2 pi divided by this number, 1/2, which is 4 pi, which makes sense. We have a horizontal stretch by a factor of 2, so our original period doubles. And remember, before we start plotting, let's set up our graph. So for the scale, remember, we take our period, which is 4 pi. We divide it up into 4 parts. So we're going to be counting by pi. So this is pi, this is 2 pi, 3 pi, 4 pi. And I'll leave the scale of the y-axis to 1, so I'll just leave it blank. Next, let's see if we can set up our midline. So remember, our midline is usually at the x-axis, but this equation has a vertical shift up 1. So our midline is going to shift up 1. Okay, and then my amplitude is 1. So I go from the midline, I go up 1, and that's my maximum. And then I can go down 1, and that's my minimum. Now we know that typically cosine starts at the maximum, but because of that vertical reflection, we're actually going to start at the minimum, which is why our first coordinate is at 0, 0. And then we kind of just follow the pattern. So we go midline, maximum, midline, minimum. And there's one full period of cosine. Remember, it is going to turn back around here, so it's important that you kind of show that curve before you draw in your arrow. And we can actually continue that pattern going to the left. So we'll go midline, maximum, midline, minimum. And there's another full period of our function. And you can see that these coordinates match what we see here. So we can see that we have pi 1, 2 pi 2, 3 pi 1, and 4 pi 0. So it all fits together really nicely. All right, so at this moment, I'm going to ask you to pause the video and see if you can give this one a try. I'd like you to complete the t-chart, determine the amplitude and period, and then sketch a graph. Okay, so go ahead and check your answers here. So a few things to notice, it was shifted up 2, so you can see our midline is now here. Our amplitude is 1, which is how I drew in the max and the min. Our period is 2 pi over pi, which gives us a period of 2. So you can see that if I split that up into 4 parts, I'm counting by half. And then you can see here's my rules for the transformation. So I had a horizontal shrink by a factor of 1 over pi, a vertical reflection, and then a shift up 2. So if you remember from our parent function, usually sine starts at the midline and then does something like this. It goes up midline, down midline. But since we have that vertical reflection, that's why it actually starts going down. Okay, let's try another one together. So here we are graphing cosine, so we'll start with our parent function coordinates. Okay, and then we're going to look at the transformations we see and determine how it will affect our coordinates. So first thing I see is that we're actually shifting to the left, pi over 2. So it's going to be x minus pi over 2. We're going to subtract pi over 2 from all of our x values. And then the other thing that we see is a vertical stretch by a factor of 3. So we multiply all of our y values by 3. So let's take a moment and update our t-chart. And you should get these 5 coordinates. So for our amplitude, remember our amplitude is going to be this a value, which is 3. And then our period, I don't see any horizontal stretch or shrink, so our period is going to remain 2 pi, just like the parent function. So let's set up our graph. The scale of our graph, we're going to take the period and split it up into 4 parts. So we're going to be counting by pi over 2 just to make our life a little bit easier. So each tick mark is pi over 2. And then let's determine our midline. So we don't have any vertical shift, so our midline is going to be the x-axis. Since our amplitude is 3, I'm going to start at the midline and go up 3 for our maximum, and then down 3 for our minimum. And now we can start plotting our points. So remember, cosine usually starts at the maximum, so it will still do this. However, we do have that shift to the left pi over 2. So our first coordinate is at negative pi over 2, 3, and then 0, 0, pi over 2, negative 3, pi 0, and 3 pi over 2, 3. So it follows that same pattern, top, middle, bottom, middle, top. And that's one full period of this function. We can easily do a second period. We do 1, 2, 3, 4. And then connect the dots. And now we have 2 full periods. Okay, let's try another one together. So here we have another horizontal shift. This one is sine, so our 5 parent function coordinates would be 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So let's look at the transformations. So here I see that we are going to shift to the right pi. So that means I will add pi to all of my x values. And here we have a horizontal reflection and a horizontal shrink by a factor of 1/2. So negative 1/2 y. We'll update our coordinates real quick. Okay, so here are our updated coordinates. Our amplitude, remember, is just this value, so our amplitude is 1/2. The negative is never going to be part of the amplitude. It's only just the vertical stretch or shrink. And then our period, there's no horizontal stretch or shrink, so it's going to stay at 2 pi. So to scale our graph, remember, I always recommend taking your period, splitting it into 4 parts, so we'll count by pi over 2. And now let's sketch in our midline and our max and min. So in this case, our midline is at y equals 0 because we don't have any vertical shift. However, since our amplitude is 1/2, that is going to change where the max and min are. So here, let's call this 1. So 1/2 would be that first tick mark. And negative 1/2 would be right here. Okay, now we can start plotting our coordinates. So our first coordinate is at pi 0, remember, because it was shifted to the right pi. And then our next coordinate is at 3 pi over 2, negative 1/2. So remember, because of this vertical reflection, our graph is actually going to go down first. And then we're going to go back to the midline, 2 pi, 0, 5 pi over 2, 1/2, and then 3 pi. And there you have it. So that's one period, and we can do the same going to the left. So 1, 2, 3, 4. And we have 2 full periods of our function. Okay, so again, go ahead and pause the video and see if you can graph this function. All right, so go ahead and check your graph. So in this case, we are going to be shifting our graph to the left by 3 pi over 2. And then we have a vertical reflection and a vertical stretch by a factor of 2. So remember, cosine usually starts at the maximum, but because of the reflection, we're going to start here at the minimum. And then we're going to go to the midline, maximum, midline, minimum. And everything, again, has been shifted to the left by 3 pi over 2. So here's my first cycle, and then I did a second cycle going to the right more. Okay, so let's try one last problem together. So this is actually more of a challenge problem because here we have a horizontal stretch or shrink and a horizontal shift. So here's one of those cases where you have to remember to factor out the 2 before you do anything else. So we do need to make sure we can rewrite our function like this. Cosine of 2 times x plus pi over 2 plus 1. So you can see here I factored out a 2. So this helps me differentiate between the shrink and the shift. So now that I have the function in a better form, we can start with our parent function coordinate. So it is cosine. So remember, we start at the maximum, then midline, then minimum, then back to the midline at 0, and then we end at the maximum. Now here we have quite a few transformations. So again, we have a horizontal shrink by a factor of 1/2. So I'm going to multiply my x values by 1/2. And then here we're actually going to the left pi over 2. So then I'm going to subtract pi over 2 from all of the x values. For the y values, we're just going to add 1 to all of them because we have that vertical shift up 1. Okay, let's update our t-chart really quick. Okay, so go ahead and check your coordinates here. In this case, our amplitude is going to be 1 because there's no vertical stretch or shrink, but our period is going to change. So remember, it's 2 pi divided by this value, 2, which is pi. Okay, so to scale our graph, we take our period, which is pi, and we divide it up into 4. So we're going to count by pi over 4 on our graph for our x-axis. Okay, so now let's sketch in our midline. So since our graph was shifted up 1, our midline will also be shifted up 1. This is our midline. Our amplitude is 1, so from the midline you can go up 1 to reach the maximum, or down 1 to reach the minimum. And now we can start plotting our coordinates. So our first coordinate is going to be at negative pi over 2, which is right here if I'm counting by pi over 4, and then 2. And then we have negative pi over 4, 1, 0, 0, pi over 4, 1, and pi over 4, 2. So here's one full cycle. And I can do another period in either direction, so I can go 1, 2, 3, 4. So I can do that pretty quickly. Or even going to the right, I could do 1, 2, 3, 4. So here I actually sketched in 3 full periods of this function. And there you have it. So remember, the key step here was factoring out this 2. If you don't factor out the 2, it's going to affect what you think the shift is. So just make sure you always check for that first. Okay, go ahead and try this last problem by yourself. We'll check your answer in just a few seconds. Okay, so again, check this first step. You do need to make sure that you factored out the pi. So it's actually sine of pi times x minus 1. So here we have a horizontal shrink by a factor of 1 over pi, a shift to the right 1. Then we have a vertical reflection and then a vertical shift down 1. So you can see our midline is shifted down. Here's our maximum and minimum because our amplitude is 1. Our period is 2 pi over pi, which is 2. So I took that, split it up into 4 parts, which is why I'm counting by half. And then here's our coordinate. So I guess our starting point here was at 1, negative 1, which is right here. And then remember, cosine or sine usually starts by going up, but since the reflection, we're going to actually go down first. So we go down, midline, up, midline. All right, that is all for today's video. Thank you so much for watching.